Hello everyone, I am Dharmendra Kumar Chaudhary, Assistant Professor in Department of Textile Chemistry at MLVTEC Bhilwara. In our online lecture series, today we will discuss about the methods of polyester dyeing with disperse dye. Before starting today's lecture, we summarize what was studied in the last two lectures. In last two lectures, we had studied about the basic concept involved in disperse dyeing of polyester fabrics, role of glass transition temperature, effect of heat setting on dyeability, role of carriers, dispersing agents, leveling agent in disperse dyeing process, and some basic properties of disperse dye as well as polyester fiber. Today we will discuss about dyeing methods. Very first we discuss about carrier dyeing method. As name suggests, in this method we use carrier as a swelling agent. And carrier reduce the glass transition temperature of the polyester fabric. So by reducing the glass transition temperature of the fiber, requirement of energy in terms of dyeing temperature is reduced. That's why carrier dyeing of polyester fabric or fiber is done around boiling temperature. Very first, as we say, carrier dyeing method is a batch wise process. Now in carrier dyeing method, very first important requirement is carrier. Use of carrier, quality of carrier, and composition, and everything about the carrier composition and carrier property is largely affect the dyeing property of the disperse dye. Carrier is an organic chemical that has affinity to polyester fabric and swell it. Chemically, these belong to hydrocarbons of substituted hydrocarbons, phenols, amides, alcohols act. Very few popular carriers are monochloro orthophenyl phenol, orthophenyl phenol, diphenyl, halogenated benzene, methyl salicylate, butyl benzoate. Function of carrier. Mechanism of carrier actions may be through increased swelling of fiber, increased water inhibitations, transport theory, increased solubility of dye in bath, film theory, liquid fiber theory, loosening of fiber structure by lowering the glass transition temperature of the fiber, lubricity of fiber molecules, increasing sites. Exact mode of working of a carrier has not been established, but it is believed that the carrier is swelling the fiber structure and lowering the glass transition temperature that facilitates the more amount of diffusion of dye inside the fiber structure. So it is believed that these swell of fiber structure longitudinally act as a lubricant, cause adsorption and diffusion of dye rapidly at lower temperature. It may be used at high temperature for a level shade. Generally, carrier is used in carrier dyeing method, but if you want and as per requirement of the shade, carrier may be used in the high temperature, high pressure dyeing method of polyester fiber to increase the depth of the shade and to get the more level shade. But in case of dyeing at boil, it is much needed comparative to high temperature. Selection of the carrier. Which type of carrier is used in disperse dyeing? That is broadly depend on the properties of the carriers. Like the selection of carrier depends on its property, chemical composition in terms of its toxicity, biodegradability, economical factors, synergetic actions on rate of dyeing, compatibility in the dye bath with other chemicals, ease in removals after dyeing, non-irritate to skins, uniformity in absorption by fiber, and have a good emulsion stability in case water insoluble, and have no adverse effect on fastness property of the shade. And how these are the basic factors which is considered during selection of the carrier, means which type of carrier should be used in the dyeing. Again, the efficiency of the carrier is depend on how it increase the amount of dye taken up by the fabrics. So efficiency of carrier can be quantified as below. Efficiency of carrier is calculated based on its acceleration factor, which is the ratio of amount of dye taken up by the fiber in presence of carrier and in absence of carrier. Acceleration factor is will be always more than 1, because in absence of carrier dye uptake will always be lower than in presence of carrier. So as acceleration factor increases, as acceleration factor above 1, it shows that the efficiency of the carrier. So it is exactly that how much of amount of dye is taken in presence of carrier comparative to absence of carrier. So we just discussed the functions of the carrier, how we can decide quantitatively that how carrier affect the dyeing property. Now we just discuss in very brief and stepwise about the carrier dyeing method of polyester fabric. In carrier dyeing method, dye bath is prepared with dye, dispersing agent, acetic acid to adjust the pH of the dyeing, which is around 5.5. Dyeing is started at 50 to 60 degrees centigrade with slow rise in temperature to 80 degrees centigrade. At 80 degrees centigrade, we add the required amount of carrier, then raise the temperature up to boil, and dyeing is continued for 1 to 2 hours, or very precisely if we say the time of dyeing is depend on depth of the shade. As for the light shade, the dyeing time is less. For the medium shade, in case of medium shade, dyeing time is higher than the light shade. In case of deep shade, dyeing time is much higher comparative to light shade and medium shade. After dyeing, dye bath is discharged, and after discharging the dye bath, dyeing is washed with anionic and non-ionic detergent along with alkali at around 60 degree temperature to remove the traces of the carrier. This process is called reduction clearing treatment. It means in this process the loose dye which is present on surface of polyester fabric is removed. Although, as we discussed, mechanism of carrier, the role of carrier, how carrier functions in polyester dyeing. So there is a various thoughts about on for the same work, but among all, most of believe that the action of carrier has been devised the more popular concept, such as swelling of fiber with ease in diffusion of dye inside. The swelled up structure subsequently collapse with cooling of bath followed by washing out of the carrier. So among all the theories and concept, it is more believable that the carrier swells up the fiber, lowering the glass transition temperature. This facilitated the entering of dye particle at lower temperature comparative to in absence of carrier. So finally it lowers the dyeing temperature by 30 degrees centigrade approximately. So dyeing is carried out at 100 degrees centigrade. Thank you very much. In the next video we will discuss about high temperature high pressure dyeing method as well as thermosol dyeing method of polyester fabric. Thank you.